Hello, my name is Namtos Diana, and this presentation is about application of machine learning operations in hard disease prediction. Yes, our project is about hard disease prediction using graph neural networks. So I'll go straight to MLOps. What is MLOps? So machine learning operations they are basically these are the practices that we use to simplify and automate machine learning workflows and deployments. So in machine learning, yes, we are working with data. You're working with data which you're training to come up with a model. So here we have our data, for the data set that we get. You train it using machine learning models. In addition to dev, which is coding and building code and building the code building which is done behind GitHub with in combination with also business operation. For example, what are the doctors or patients or clients needing from this? So in combination of a combination of all this comes up with this is what we call machine learning operations. And by using this, we're going to one comes up with a model with that project in that project. So a continuation of that, yes, as you start working on your machine learning project, you start from data gathering. Then you analyze it all the way until you build the full model. Then when you're finding some wrong predictions or not giving you what you want, you're going to retrain that model. So using machine learning operations, we are going to work on 4 different things and 4 different ways. So 25% of efforts and the time you're putting it on DevOps like collaboration as a team, how you're going to work on the project, and then 25% on the data, for example, yes, that operations, cleaning the data and all that. And then 25% will be on training the models, and then 25% on the business needs of the project. So next, I'll talk about how relevant these MLOps are to hard disease detection or prediction. So it is relevant, and this is how relevant it is because it's going to give us it's a way for reliability. Reliability now that, for example, we are writing code, we are not working on it individually. We are working on it as a group. So one person is going to work on one thing, another one on the other. So, for example, as we are doing the code, we are pushing it to GitHub. So that is the platform you're going to use. So it is reliable in a way that it seamlessly integrates this code and avoids error and or incompetencies. Yes, so that's how how relevant it is. We don't need any errors in the project. Anyone doesn't need that. So yes, seamless integration as everyone is pushing to the repo. It integrates them without you having to see. And then scalability in that if we ever want to, we have done some features in the model and then maybe we want to add on some functionalities. So it is going to help us in that way of scalability. And then deployment and monitoring of our graph neural network model and maintaining the system and also optimizing its performance. So that's how relevant it is. Then for the trends and techniques, yes, it's all about machine learning operations, all about continuous integration and delivery, which help in rapidly iterating the deployment models and getting along with the updates, which enhances accuracy and reliability of the model results. So the trends that are there is there's network file system operations, there's Kaizen machine learning, there's edge-based machine learning and Kubernetes. But the interest from what I've learned from the video and the knowledge we have, we are going to use a Kaizen machine learning trend or technique because this supports continuous integration, we are going to be writing this code and making small increments to our GitHub repos and working together. When we reach a moment, we reach the last stage of deployment. If something is wrong, we are going to go back to the beginning of the model. That's why we are going to choose this as a machine learning model because of its agility. and recursiveness. So DevOps and data ops. So DevOps, as we're working as a team on this project, is going to help us to collaborate and easily communicate with each other. For example, if someone is doing something, you're doing a code, and then if you're writing code, you come up maybe with you're getting bugs or you don't know what to do, like easily communicate with colleagues to find help. They tell you what to do. And then data ops, data operations, we have already done this. We did this last week, batch one, when we did the exploratory data analysis by cleaning the data with there was missing values, and then there was duplicates. So we already did that on the data. So that's basically what is under data operations. And then here on the right, yes, it's just talking about DevOps, which is about team collaboration as you're going through the development process. So next is are we going to is our project going to require us to use heavy MLOps or light MLOps? From in our project, we're going to use both of them because we are dealing with a lot of data and it's kind of complex when using graphical neural networks. So first, the light MLOps, just writing code, uploading to GitHub, and then yes, when you run the model is going to give you a prediction. Then in heavy, we are dealing with data centric in that you have collected the data, and then you're going to operate on it, do the data ops on it, and then after it's clean, you're going to train the model. Here on the right, it's model centric. So you're going to use this data to train the model. So we are going to use a combination of this, getting the data, working on it, developing the models and training them. And then as we write our code, we are pushing it on GitHub, which is going to be connecting us to cloud services, for example, Amazon and or Google Cloud Services. So how we're going to handle data poisoning, data drift, then microservices. So data poisoning, these are the irregularities and incompetencies in data. So we are going to mitigate this through like doing the data validation and cleaning, also the feature engineering to get rid of these incompetencies in the data, to come up with quality data. Then for data drift, this is as you go the data, in the background, something can be happening, causing changes in the data without you noticing. So to mitigate this, or to mitigate this data drift, we have to be monitoring our feature store, in this case our data set, and always keeping it up to date, cleaning the data, just checking it up. And then for the operationalizing microservices, an example I'll use here is GitHub. I'll keep talking about GitHub because it's really going to be the base of leading us to the cloud services. Yes, it will help us in scalability and maintaining the whole process on the project. So yes, it's about continuous integration and delivery, as I've mentioned above. Yes, as you write code, you always making small increments. You push it to the GitHub, and then in the background, there's building taking place, and that's continuous delivery. That's how it's going to be helping us. And the diagram, you build code and then deploy. The process continues, keeping also like going along with the current updates to get rid of errors and incompetencies. So for the feature stores, at the moment, you're going to be using the data set, which is having all the features that we need to train the model. In the diagram, yes, for example, here application, enter the raw data into the feature store, which is our data set. And then as a doctor is using this app, he's going to enter these features, which the model is going to give them the prediction whether the patient has the disease or not. So for the files, you're going to create files like the requirements file for the requirements of the project, then the setup, the README file. For example, when we push it to the GitHub repo, we shall need a README file talking about the project, the make file. Yes, all this will help us to document the dependencies and the whole process of our development. Yes, then the hierarchy, just a reminder, this is what I've been talking about from up there. And then I'll talk about the pyramid on the right, whereby at the base of it, at the lower level, is the DevOps, where as a team, as a group, we're going to be working together to do the code here using infrastructure as code. Then the next stage is data ops, which we already did. We we have done some of it through the exploratory data analysis. Then the platform automation, for example, yeah, we're going to use platform like GitHub. We're going to use GitHub, and then the platform for development like yeah, the IDEs. And then at the top of the pyramid is machine learning ops themselves. So here where we shall need to put into consideration the business requirements, and then and the problem that you're working on, which is hard disease prediction. And then with the features that we have, we are going to unsupervised learning. We shall discover patterns, and then at the end of it, we will make what? The model will be able to make predictions. And all this, it's an automation process from the lower level to the upper level of machine learning. So in summary, why are we using machine learning operations? First of all, it's about collaboration and communication with the DevOps, and then efficiently deploying the model, continuous integration, continuous deployment, scalability, and the rest. That's why we are choosing to use, and anyone else doing a machine learning project would have to use machine learning operations. Yeah, in conclusion, it really plays an important and crucial role in optimizing development and deployment of our hard disease detection model, which will ensure reliability, accuracy, and scalability. Then above all, automation. Yeah, future considerations will be improvements in the MLOps practices to adopt like a following data and model requirements that might be required depending on the business models or what the doctors require of the model. Yeah, and these are my references. That's where I got the information. Thank you so very much.